Today we are going to discuss. Okay. Today we are going to discuss about that what are the remaining chapters which are present in that air pollution control technologies. Today, I wish you a very happy International Women's Day once again. Here I'm going to share my screen. Uh, just wait. So, this is the block 10. Already we discussed that what are the control methods, source, and that correlation methods of air pollution in that last class. Then coming to that next chapter 11, coming to that. Yes. Then coming to that one, coming to the next one. Yes. Unit 11, air pollution control and the emission reduction technologies already we discussed in last class. But if you anyway, this is somewhat difficult. That's why going go. I'm going to through this one again once again. Why? Because it is a very difficult chapter. I'm not that much of a difficult. But better to listen one more time. Why? Because some new words and new technologies will be introduced in this air pollution control, emissions and reduction technologies. Okay. In Unit 11, it is included that air pollution control and emission reduction technologies. Air pollution control technologies are designed to reduce or eliminate the release of the harmful pollutants from the industrial, transportation, and the domestic sources. These technologies can be categorized based on the type of pollutants they targeted, but particulate matter, that is nothing but the PM, is next is the gaseous pollutants, sulfur compounds, nitrogen compounds, carbon compounds, and volatile organic compounds, and the toxic heavily metals. So these are the just introduction about that air pollution control and emission reduction technologies. Control technologies for that particulate matter. Particulate matter includes a fine particles. So particulate matter includes the fine particles 2.5 m and the particulate matter 10 that causes a severe respiratory and the environmental issues. From the starting onwards, we are going to discuss about this one, which the particle have that particulate matter capacity is a 2.5 at 10. It is a very dangerous. Electrostatic precipitators. ESP means electrostatic precipitators. Okay, use electrical charges to remove a fine particulates from that exhaust gases. So by using the electricity, you can charge, or we are going to remove the particles which are present from that exhausted gases, commonly used in the power plants, cement industries, and the steel plants. The efficiency of that electrostatic precipitators are 99% removal of a fine particulates. Then coming to that next one, a cyclone separators use a centrifugal force to separate a large particles from the air stream. So use a centrifugal force to separate a large particles from that air stream by using this cyclone separators. Common in a cement production, sawmills, and that the food processing industries. These are the most useful things. The capacity and the efficiency of the cyclone separators are 50 to 90% for the larger particles. Then coming to the next one, fabric filters. The fabric filters are also known as the baghouse filters. Use fabric membrane, a membrane to trap the particulate matter, to trap that particulate effective in coal-fired power plants, chemical industries, and that the metal processing units. The efficiency of the baghouse filters are over 99% and removal of particulate matter. These are the having the capacity to remove the particulate matter up to 99%. Then coming to that next one, that is nothing but the wet scrubbers. uses a liquid, usually water, to capture a dust and the soluble pollutant, to capture a dust and the soluble pollutants which are released from the industries like a chemical processing plants. Up to 90, it having the capacity of the efficiency up to 95% more for the particulate matter, and but produces as a wastewater. Then coming to that next one, a control technologies for gaseous pollutants, sulfur compounds, nitrogen compounds, carbon compounds, and volatile organic compounds. Coming to the first one, sulfur dioxide. How to control the sulfur dioxide? So a flue gas desulfurization, FGD. FGD is nothing but a flue gas desulfurization. Uses a limestone slurry to absorb the SO2 from the exhaust gases. By using that, a limestone slurry to intake the sulfur gas from that exhaust gases, applied in fried power plants. Coal fried power plants, if the capacity, efficiency, it has the efficiency of to remove that sulfur dioxide compounds up to 90 to 95%. Next one is the dry sorbent injection. Dry sorbent injection uses of alkali substances like a sodium bicarbonate to neutralize the acidic gases. By using that alkaline substances like sodium and bicarbonate, you can neutralize the what are the acidic gases which were released from the small industries, boilers, and that waste incinerators. The efficiency of this particular dry sorbent injection is 70 to 85%. Okay, then coming to the next one, nitrogen oxides control. How to control the nitrogen oxides? Selective catalytic reduction, SCR, that is nothing but a selective catalytic reduction. It injects the ammonia, NH3, or urea into the flue gas, converting the nitrogen into the N2 and the water. It injects that ammonia or the particular the selective injection of ammonia can enter into urea through into a flue gas. The particular thing can convert the nitrogen into separate molecules, water and the nitrogen. It is mainly, it's very helpful in the power plants, refineries, and that industrial boilers. Up to 90% of the, it having the up to 90% of efficiency to remove the nitrogen reductions. Selective non-catalytic reductions. Selective non-catalytic reduction. First one is the selective catalytic reduction. Second one is the selective non-catalytic reductions. Similar to uh, similar to the selective catalytic reduction only, but it does not use the any catalyst. In this one, we are not going to use that any catalyst applied in the cement, kilns, and incinerators. Efficiency up to 30 to 35% when compared to the SCR, that is nothing but selective catalytic reduction. The efficiency is that very low. The next one is the low nitrogen burners, LNB, low nitrogen burners. Optimizes the consumptions to reduce the nitrogen formations used in the industrial furnaces and the boilers. The efficiency up to 50% to remove the nitrogen compounds and reductions. Right? Then coming to that next one, uh, carbon dioxide control. Carbon dioxide control. In the carbon dioxide controls, again, three methods are mentioned. Carbon capture and the storage is the first one. The short form of the carbon capture and the storage, CCS. Capture CO2 emissions from the power plants and that industrial sources. It captures the what are the emissions from the power plants and the industrial sources. It stores carbon dioxide underground to prevent it from entering into the atmosphere. The what are the how much amount of the carbon dioxide which it can be emitted from the power plants and industrial sources, which can be stored in the underground, do not enter into the atmosphere. The efficiency is up to 85 to 95% to capture the carbon dioxide, but I'm not going to vote this one. Why? Because if that carbon dioxide, how we can store that carbon dioxide, if maybe if the large amount of carbon dioxide, if any accidentally or any natural disasters or anything will happen, directly a large amount of carbon dioxide will be enter. How that atmosphere can take that one? What are the disasters and what are the things which will happen in that future because of this? Actually, we don't know. I'm not going to prefer this one. Okay, this is the only one. This is the one of the method. That's it. But it is not a correct method as of my thinking. Sorry for the disturbance. Post combustion capture uses a chemical solvents like amines to absorb the carbon dioxide from exhaust gases. So the uses of the chemical solvents like amines to absorb the carbon dioxide from the exhaust gases. It applied in the coal and the natural gas power plants. Natural gas power plants. The next one is the pre-combustion capture. Converts the fuel into a hydrogen and the carbon dioxide before the combustion. Conversion converts the fuel into hydrogen, convert the fuel into hydrogen before that fuel can convert into carbon dioxide. Use in that integrated gasification combined cycle. In this particular thing, we are going to use that IGCC plants, that is nothing but integrated classification combined cycles, right? Then coming to the next one, a direct air capture, DAC. It extract the carbon dioxide directly from the atmosphere, emerging technology with the high cost. It is the high cost and it is economically not recommended. Uh, it extract that carbon dioxide directly from the atmosphere. So the unwanted amount of the carbon dioxide which are present in our atmosphere, it can be absorbed by the direct air captures of carbon dioxide. Okay, then coming to the next one, the volatile organic compounds. Coming to the next one, last one, that is that volatile organic compounds control. Activated carbon adsorption. It is not a absorption, it is the adsorption, AD. Uses to carbon to trap the volatile organic compounds from the industrial emissions. From the industrial emissions, we are going to use that carbon traps applied in that chemical manufacturing and solvent-based industries. We are going to applied this particular activated carbon absorption method in that chemical manufacturing and that solvent-based industries. The efficiency of this one is up to 90 to 95%. That is a very good thing. Then coming to the next one, a thermal oxidizers. Burns the volatiles organic compounds at high temperatures to convert them into carbon dioxide and water. To burn the released volatile organic compounds at high temperature to convert into a carbon dioxide and water. Used in a paint, printing, and that a chemical industries. So what are the painted industries, what are the printing industries, and what are the chemical industries? This is the thermal oxidizers process is the most uh, useful method to control the volatile organic compounds. That is nothing but the thermal oxidizers. Catalytic oxidizers uses catalytic to oxidize the volatile organic compounds at that lower temperatures, common in automobile and that industrial applications. Then coming to that next one, control technologies for the heavy metals and the toxic emissions. Heavy metals and the toxic emissions are mercury, Mg. Mg control the activated carbon injection, ACI. It injects the activated carbon. Uh, so injects the activated carbon into that flue gas that is the captured mercury applied in the coal-fired power plants and that Coal plants power applied in that coal fried power plants efficiency up to 90%. Next one is the wet scrubbers and removes the water soluble mercury compounds by using the wet scrubbers used in chemical and metal industries. Next one is the dioxins and the furans control the high temperature inertions. The high temperature inertions burn waste at the less than greater than 1000 degrees centigrade to destroy the toxic dioxins. Used this method is a very useful way that in medical and that hazardous waste incinerators are there. Then coming to the next one, catalytic destruction use as a metal catalytes to break down the dioxins at that lower temperatures. By using this catalytic destruction, we are going to break that mm, uh, we are going to break that what are the metal dioxins. Okay. Then coming to the next one, uh, emerging and the future technologies. The future technologies, right? Electrochemical reduction of carbon dioxide. What is the electrochemical reduction of the carbon dioxide means to convert the carbon dioxide into a useful products like fuels. It is the best process, but still it is in a research level, and we are going to hope, we are giving that all our best wishes and hope for the good, for good for their success. If who are the people which are involved in the research of converting of the carbon dioxide into fuels, they are definitely going to success and develop into a new phase. That is a one great milestone in that environmental technologies if this research will be succeeded. Okay, I wish you very all the best to other researchers which are including in this one, right? Then coming to the next one, biofiltration for the volatile organic compounds removal. Uses bacteria to degrade the organic pollutants. So by using that bacterials, you are going to degrade the organic pollutants. It is a very useful in the waste treatment plants. Then coming to the nanotechnology based filters. So here nano means small. So what are the uses of the nanomaterials to capture the pollutants efficiency? So what are the efficiency of the pollutant that can be captured by using that nanomaterials? The high potential for that automobiles exhausts and that industrial applications. High potential for the automobile exhausts and that industrial applications. These are the very useful things. Then coming to that conclusion of this chapter topic, different air pollution control technologies are used. Mm, Based on a type of pollutants, emission source, uh, and the regulatory requirements. The advanced solutions like the carbon capture, electrostatic respirators, SSER, selective catalytic reductions, and the volatile organic oxidations, and play a crucial role in reducing the harmful emissions. Future developments in nanotechnology and the biofiltration offer promising the improvement in the air pollution management. These are the conclusion. Then coming to that next unit which are including in the block 3, that is nothing but controlling the specific air pollutant sources involves the implementing targeted strategies to reduce the emission from the various industries, transportations and other sources. Here the overview of the approaches. So how that particular air pollutant sources will be involved in this air pollutions, and what are the strategies and how can we reduce from that various ways which we are going to discuss in that unit 12 block 3. Okay. um 7. Okay. Okay. What are the first one is the industrial sources. So what are the industrial sources means emission control technologies, electrostatic respirators, remove the particulate matter from the industrial exhausted gases, scrubbers used in power plants and that factories to remove the sulfur dioxides and the other pollutants, and the selective catalytic reductions reduce the nitrogen oxides, right? Emissions from the power plants. Third one is the activated carbon adsorption. It removes the volatile organic compounds and then hazardous air pollutants. Regulatory compliance is nothing but the industries must flow a Clean Air Act regulations must follow that air clean regulations are equivalent national laws to limit the emissions of that particular pollutants. Permitting systems require industries to meet the emission standards, to meet that emission standards. Then coming to the next one, transportation sources. This is the most important source of that all the air pollutants which were from generated, right? But without transportation, there is a no development, okay? But we are going to concentrate on that our atmosphere also. So many new technologies and new ways and new laws will be there to control that what is the transport sources of pollutions, while each and everyone voluntarily they are going to participate and they are going to follow the environment laws. That is a very good thing. I hope all the human beings are try to understand the what is the condition of our atmosphere and what are the emissions, how much of the emissions can enter into our atmosphere, how can we control, just to follow that basic rules. Then only we can give the a sustainable and a beautiful environment to our future generations, right? And coming to that next one, transportation sources, a vehicle emission standards. In that first one is that a vehicle emission standard absorption of Euro 6. Euro 6 Type 3 and a similar vehicle emission norms to limit that nitrogen and carbon and that particulate emissions. Okay, this is the most important thing. Then next one is phasing out older high emission vehicles, phasing out that high older emission vehicles. The next one is the alternative fuel and the technologies. So what is the alternating fuel here means in that in that unit level, at research level, we discussed one thing, the carbon dioxide can be converted into fuel. That is the new hope for that alternative fuels at promoting the electrical vehicles, e-vehicles and that hydrogen fuel cells. The next one is the encouraging biofuels and that a cleaner combustion technologies. Introducing that are introduced as well as the encourage of the uses of the biofuel in that society as well as the combustion technologies, cleaner combustion technologies we have to follow for that were vehicles. Then next one is the traffic management and the public transport. So implementing conjunctions, pricing and that law emission zones in cities. That is a not law, that is a law. LOW, right? Once again, I am going to read that one, the traffic management and the public transport, implementing conscious pricing and that low emission zones in cities. Then next one is the expanding public transportation and the non-motorized transport infrastructures. For example, metro. Then before that metro, mainly up to 30 to 35% of the daily travelers can adopt uh, as a what are that MMTS. MMTS. When that particular metro will come into force, so up to 60 to 70%, up to 60 to 70% daily daily people who are going to take transportation sources, they are switched on into a metro. That is a very affordable and safe and on time journey. That is a very good thing. But so the percentage of the people who are going to travel in that metros, it will be increased daily. That is a very good sign. That is the most important thing here I'm going to discuss with you, with all of you. Then coming to that next one, the agricultural livestock sources are reducing the ammonia and methane emissions. So reducing the ammonia usage as a fertilizers and as a fungicides and the pesticides, as a nutrient for that plants, for their growing and blooming, and the flowering and the cropping seasons, and also control the emissions of the methane by using that what are the livestock which are going to raise, that is nothing but the cows, buffaloes, goats. These are the main source to produce the methane. But India is the one of the most important country which you are directly or indirectly, which will depend on your livestock and rearings. So many people, they are going to took their lives from that livestock only, livestock rearing only. Uh, then coming to the point, optimizing the fertilizers used to minimize the ammonia emissions, used to minimize that ammonia emissions, are promoting sustainable livestock feed. It can be promote the sustainable livestock feed, and manure management is the most important thing to control the flies and all, smells and the flies and all in our surroundings, in our houses. When we are going to maintain that manures at good level, that is a very good. Then coming to the open controlling of the open burning. Open burning control. What is the open burning control means? After that crop reductions, after that crop reductions, to reduce that burning of the crops in that particular agricultural fields. So when we are going to burn that particular crops or residues which in that particular field, then what will happen? The large amount of the carbon dioxide as well as the methane can directly enter into our atmosphere. That is also a very bad thing. It can also shows the adverse effect on the particular agricultural soil field, soil health also. When we are going to burn, then what will happen? What are the good bacteria and what are the friendly bacteria? And the good friends of the farmers are nothing but the earthworms. It can be dying due to that large amount of heat which can be produced in that burning. And what are the fuels which are going to use in that burning? That is the petrol. It can disturb the soil health, and it can kill the water, the good microorganisms and the earthworms which are present in that particular agricultural land. Then finally, what will happen? The particular fertile land can become into a barren land due to this type of a practices. That's why here we are suggesting that to control the open burning, banning or restricting of the crop residues burning. Then coming to the next one, promoting a sustainable agricultural waste management, bio biochar biochar composting. So you can manage the water, the waste products which are coming from that agricultural practices, that can be converted into a composting. That may be most of the important thing to control that what are the pollutants which were released into the atmosphere due to the practice of the agriculture and livestock. Okay. Then coming to the fourth one, that is nothing but a residential and the commercial sources. So household energy solutions. In that first one is that household energy transporting. And what is the transitioning from the biomass coal stoves to clear the alternatives, to cleaner alternative and LPG, electric and solar cooker stoves. Okay, this is already done. All the things which were practiced in this part, first point. Why? Because in nowadays there is no biomass and coal stoves for the cooking, for the open cooking and for the open burning. In that rural areas also, for each and every woman can switch it into that LPG. In that urban area, some people can switch it into that electric and solar cook stoves. So it is up to 70 to 80%. We are going to follow this one. We are not going to bother about this first point. Then improving energy efficiency in heating systems. So we can concentrate on that particular heating system, particular heating system, and improving the energy efficiency, improving that energy efficiency. Then next one is the reducing volatile organic compounds. Can you reduce that volatile organic compounds? Encouraging the low volatile compounds, paint, adhesives, and that household products, enhancing that ventilation and the indoor environments. So these are the best 2 points which are going to follow to control the residential and commercial source of pollution. Then coming to that next one, waste management. Coming to the next one is nothing but a waste management, a landfill gas recovery, a capturing the methane from the landfills for energy production. Well, we are going to use that a methane as a fuel or a gas or anything that is a good thing. Methane is easily and cheaply available in our atmosphere because our agricultural practices as well as that livestock rearing also. Waste insertion controls using the advanced filtration systems. We are going to use that advanced filtration systems to reduce the dioxins and the particulate emissions, to reduce that dioxins as well as that particulate emissions. Coming to the sixth one is nothing but a natural sources. Forest fire management. So in this okay, forest fire seasons will already come, is nothing but in that summer season the forest fire commonly will happen in that Amazon forest. Not only in the Amazon forest, where that forest will be there, some forest fires will be takes place due to some high temperature conditions and all. The implementing control burns to reduce the large scale wildfires, enhancing fire monitoring and a response system. It is the most important thing which we are going to follow. The next one is the dust control, using water sprays and that vegetation to minimize the dust from construction sites and the unpaved roads. So dust control is the one of the most important thing. Okay. Then here coming to that, the working principle of the electrostatic precipitators. So where the particular electrostatic precipitators are there? Here, the electrostatic precipitators. So in that electrostatic precipitators is also known as the ESP. It can remove a particulate matter from industrial exhaust gases, right? Here one picture will can represent that what are the working principles of the electrostatic precipitators. So this is a diagram of a uh, what are that electrostatic precipitators. So here three colors will be there. The first one yellow, and second one is the blue, and third one is the pink one. Here we can observe very clearly. Uh, First one is that electric field which you are mentioned here. Next one is a charged particle, and next one is a discharge electrode at a negative polarity. Discharged at that negative polarity. When first from this, what are the arrows can be included? Is here is nothing but a gas flow. The uncharged particles from this sides, then clean gas will be exist. Okay, for example, we can imagine this as a empty, what is a tube like structure. The upper side of the wall, can be charged as a positively. The lower side also can be charged as the positively. Then what will happen? uh, we can going to create that electric fields in that particular tube like structure. First one, we can create that electric field, and then what will happen after creating that electric field? We are going to enter the gas. So here gas means what type of gas we are going to flow through this tube-like structures. That is nothing but the electrostatic precipitator is nothing but what are the chemical gases? What are the chemical gases? So where that particular electrostatic precipitator can be used? Uh, So the electrostatic preparators can be used at a what? Where? We are going to, already we discussed, right? Where that particular electrostatic precipitators. Wait. Yes, here it is. The electrostatic preparators uses electrical charges, as I said, right? The upper part is charged with the charged upper part and lower part will be charged to remove the fine particulates. So remove the fine and small particulates from the what are the gas. Okay, what are the gas which are commonly produced from the power plants, cement industries and steel plants. Okay, can you remind that one here? Yes. Okay. The upper part is charged. The lower part is also a charged one. This is the electric field which is present in between the two charges. Okay, where that particular electrostatic respirators can be used means what are the gases which can be produced from that power plants, cement plants and that steel plants. Okay, in this particular three industries only, the electrostatic respirators are the very useful ones. Okay, when we are going to create that some electric field between these charged particles, we can flow the gas which get released from that power plant. It may be a cement plant, it may be a steel plant. Then what will happen? The power will be worked that between the flow, between the gas flow can enter into this one. What are the negative particles which will be present? It can become and it can attach it to the both sides of that particular walls. What are the positively charged particles? What are the negatively charged particles? It can be come and it can be attracted by the, it's a negative charge. That is nothing but a positive charge can be attracted by a negative charge or then what will happen? What are the negative molecules which will dispersed from that both sides? It can attach to the both sides of the walls of that particular tube. Then what will happen? What are the positive charged particles? Means what are the good particles? What are the good particles? Which particles are not going to harm at any cost to our environment? That are the particles are the positively charged particle. It can easily go through from this tube. That is nothing but the clean exhaust gas. It has the capacity, it has the efficiency to clear the what are the dirty gas which are from that in the cement industries, steel industries, as well as that power plants. What are the gas which are coming from the clean gas exist? That is the good. It is the most important thing. It is a very beautiful thing to remove the unwanted particles. And what are the particles which are going to affect the environment? It can be removed by electrostatic precipitator. This is a very beautiful one. It is a very appreciable one. Okay, up to here, everything is clear. I hope that. Then coming to that next one, emission control technologies, sorry, two times I mentioned here. Wait, I am going to remove one time. Okay. Okay. Coming to that next one, emission control technologies. So what are the emission control technologies which we are going to use? Okay. Then move to that chapter unit 11. First one is the electrostatic precipitators, already we explained. Then next one is the, what was that? Emission technologies. Where it is? Cyclone separator, fabric filter. Wait for 2 more minutes. Emission control technologies, right? Here, emission control technologies. Okay. Emission control technologies means in that emission control technologies only, the electrostatic respirators are the one of the most important one, which takes place, in the first to play first in that row. Then next one is the emission control technologies. In that emission control technologies, we are going to explain the total thing. In that 1, 2, 3, 4, 5 and the 6, 7 and 8 chambers will be there. So how it will be worked is mean here we are going to explain, right? Uh, First chamber named as a particulate filter. First one is a particulate filter and second one is that mixing unit and injection nozzle and third one is the selective catalytic reactors. So SCR means selective catalytic reactors. By using the catalyst, we are going to remove the what are the harmful products, what are the harmful gases which we are produced, and what are the uh, what are the positive charge? It may be a negative charged particle which can be removed from that air by using this emission control technologies. And coming to that fourth chamber named as a oxidation catalyst. And fifth one is the clean exhaust. So fifth one is a clean exhaust. First one is the dirty exhaust and second one is the clean exhaust. When coming to the internal parts of this one is the use use what is that? Urea dosing unit, urea pump, and that what are that edges, again aqueous urea or the ammonium solution tank. This is a temperature sensor. This is also a temperature sensor and a nitrogen and that ammonium analyzers we are going to use at this stage 4. Then finally air compressor. Finally that is that this is the overall look about that what are the emission control technologies. Okay. Then coming to the explanation of this picture clearly. First, we are going to enter the dirty gas in the particulate filter. Then particulate filter. Then what will happen in this particulate filter means all the equipment which we are made by which are made by the metal is nothing but a cast iron. That is nothing but the a cast iron things. That particular iron have the capacity to hold the dirty exhausts and the catalytics and what are the reactions which takes place in this particular equipment, for all the reactions and for all the good and bad things that particular uh, that particular equipment can support. um, these are the a good manufactured one and to control that emissions in that environment. Coming to that first one, when that a dusty exhaust can enter in that chamber one. In that chamber one, there is no any small equipments or no any small machines to control this. Just a particulate filters will be fitted in this part chamber one. In this chamber one, the particulated filters are there. Then what will happen when that particular dirty gas can enter in that particulate filter? Then what will happen? How much amount of the what are the capacity of the particulate filter? uh, how that capacity will be worked up to 100% when that particular dirty gas can enter into that particulate filters. Then what are the dust particles and what are the particulate matter is between the 2.5 to 10 that can be stopped at that outside of the filters only, outside of the particulate filters only. only some amount of it dust. Okay, that is all, that is after particulate filter also it is called as a dirty exhaust only, or only 10% of the dirtiness of that particular exhausts will be removed in this first chamber, that is called as a particulate filters. After the completion and the remaining only 10% will be removed. Here the remaining part can enter into the next chamber. In this chamber, we are going to use that two types. First one is a mixing unit. First two units are there. In that first one is that mixing unit. What is the mixing unit? Why you are going to mixing here? What it may be a chemicals, it may be a solids, it may be a anything. What is the need of the mixing of that dirty exhausts at a level 2? So here why they are going to mention this is a mixing unit means, in this mixing unit means when that particular dirty gas can enter into the second chamber, then what will happen? It can be mixed within that in that only. Means there are no any chemicals, no any other liquids, no other added compounds can enter into the dirty gas. Only the dirty gas only will take the rotators as a clockwise and that and the anti-clockwise direction to mix very well what are the remaining dust particles which are present in that air after the particular filtration. So after mixing of that particular thing, ingestion, the particular air can enter into that ingestion nozzle. What is the importance and what is that ingestion nozzle and what is the importance of the ingestion nozzle? So here ingestion nozzle means after the mixing, after the clockwise and the anti-clockwise rotators of that particular dirty exhauster, then what will happen? The gas can directly ingestion into the SCR catalyst. What is SCR catalyst here means selective catalyst reactors. Already we discussed in that chapter 11. That is the most important one in this thing. We are going to use a catalyst. It may be a ammonia. Here, they just see here. Already we made, already explained that one. Selective here. See, selective catalytic reduction, SCR, it reduce the nitrogen oxides emissions from the power plants. Okay, what are the dirty gas which are having the nitrogenous compounds? It can be controlled by a catalyst in that selective catalytic reduction process. It have the clear explanation in this chapter 11. Mm, wait, I'm going to see. I'm going to see you. Yes, here. A selective catalytic reduction. Ingestion of ammonia means what is the catalytic here? What is the catalyte here? What is the catalyte here means that is nothing but that ammonia. So a selective catalytic reduction. Oh, I'm sorry. It is not in this type mode actually. I'm sorry. Uh, Again, it will be like that only. I am so sorry, but I'm not. Okay. See here a selective catalytic reduction. In this particular selective catalytic reduction, we are going to use ammonia or urea as a catalytes, as a catalyst. First, what is that? Ammonia as well as a urea used as a catalytes. into the a flue gas. It may be a dirty gas. Then what will happen by using these catalytic reactants, that is nothing but the ammonia as well as the uh, urea is going to react with the flue gas and convert nitrogen NOx nitrogen compounds into a nitrogen as well as that a water. It can break down the what are the harmful products, what are the harmful compounds which are formed with the combination of the nitrogen compounds as well as the water. It can be breakable. Then what will happen if the things will be breakable? The harmness of that particular chemicals will be decreased. That's why here we are going to use a selective catalytic reductions. Okay. Then coming to that picture. No, sorry. Yes. Here, this is the dirty exhausted which can enter into this first one, that is called as a particulate filters. In this one, there are some particulate filters. It may be like this. Sorry, I'm not good at the diagrams, but for that clear and easy understanding, here I'm going to try something. Uh, These are the particulate filters which are present in this first chamber. When that particular dirty gas can directly enter into this one, then what will happen? What are the particulate matter is a 2.5 to 10. It can be removed by the filters, and what are the remaining gas which are present that can directly enter into this particular mixing area. After the mixing, that can be converted, it can be entered into the ingestion nozzle, and this is that ingestion nozzle. Then what will happen when that particular ingestion nozzle, okay, then in that particular ingestion nozzle only we are going to give the catalyst. Before that what are the dirty gas can enter into the chamber number 3 as well as the chamber number 4. Before that only we are going to add the catalyst, right? Before going to that only we are going to add the catalyst. Here we are going to use the urea as a dosing unit, as nothing but a catalyst, or nothing but a catalyst. Not only urea, it is also a ammonia. Based on that, what are the dirty gas and what are the dirty exhausted, from which plant, from which industries it can be released. And already that people have some idea about that what are the compounds which are present in that emissions of cement industry. It may be a steel industry, it may be power plants. Based on that, they are going to use the catalyst. Here most important catalyst is nothing but the urea as well as that next one is that ammonia. So ammonia. So ammonia. So ammonia as well as that urea using as a dosage unit before that gas can directly enter into the ingestion zone. Uh, Before that only we are going to treat that, we are going to ready to fill the urea as a catalyst. And this is that an aquatic urea. Aquatic urea is nothing but that is nothing but a soluble urea. This is nothing but a soluble urea, ammonia solution. Urea and plus ammonia solution in tank. It is a temperature sensor. At what is the temperature? It can be there. Okay, na? It may be a cold, it may be a hot, it may be a up to some percent hot, it may be a 50 degrees, it may be a 30 degrees. When that particular temperature at that 30 degrees, it can be worked as a good. Maybe it may be a 20, it means worked as a very well. Based on that type of a gas and the dosage of that particular urea and ammonia. mm, the temperature will be based on that. Okay, we have the connection from that aqueous solution tank of the urea and ammonia. That is nothing but the urea pump. Through this urea pump, it can be entered. It can be into a urea dosage unit. It can be stored here. It can be wait, wait waiting for that particular dirty gas. When that particular dirty gas can enter into the second zone with the mixing of this what are the catalyst means what is the urea and ammonia solution, it can be mixed and it can enter into that SCR catalyst. Then what will happen, these are the catalyst, right? Urea and the ammonium are act as a catalyst. When these are going to react with this one, then what will happen? Here I am going to mention what will happen means nitrogen compounds can break down in presence of in that particular SCR reactants means urea as well as ammonia. It gives nitrogen plus water. So this is the reaction which can be takes placed in this particular SCR catalytic region is nothing but chamber 3. Okay, then next one is the oxidation catalyst. In that oxidation catalyst and what will happen? In oxidation catalyst also we are going to maintain some temperature. For the temperature testing, we are going to use the temperature sensors. We are going to use that temperature sensor, oxidation catalyst and all. After this process will happen, then what will be, these are the released from that exhausting. This can be released as a clean exhausters. And this is the clear explanation about that what are the emission control technologies which were used in that power plants, which are used in that the power plants, cement industries and the steel industries. Okay. Uh, just I'm going to remove all these things. If we are in class, we have a direct class, then what will happen? Just we are going to remove the blackboard with the duster. But It is somewhat a difficult, but not a difficult. That is a, not a natural thing. I don't know why this. Just wait for a few minutes. It will be completed. Few more minutes. Not a minutes. Few more seconds, please. Yes, it's clear. Then coming to that next one. What is this? This is nothing but the wet scrubbers. Wet scrubbers. Select two catalytic reductions. Okay. And these are the scrubbers. So what is a scrubber here? So what is a scrubber here means already we discussed in that scrubbers are the most important pollution control emission control technologies. Scrubbers also to place a clear role to control the emissions and to remove the what are the chemical compounds and what are that sludge and what are the waste which are present in that gases. In the scrubber also two types are there. First one is the wet scrubbers and second one is the dry scrubbers. And the when compared to the both wet scrubber and the dry scrubbers are the wet scrubbers are the most important and have the efficiency to remove the impurities and the unwanted substance from that gases as well as that solutions. So this is that a scrubber. These are the industrial scrubber. Just wait. What is the importance of the scrubber I mentioned here? Just I am going to show you. Where it is. Wait. In maybe cycle 11th, it was, yes. This is the wet scrubbing. This is the wet scrubbing. This is the wet scrubbing. It removes the water-soluble mercury compounds. Most important one, the heavy metal removal. For that heavy metal removal, we are going to use that the wet scrubbers used in the chemical and metal industries, which is mainly used in that chemical and as well as the metal industries. Right? Clear? Just to keep it in your mind. These are the wet scrubbers which are used in that chemical and the metal industries to remove the heavy metal, one of the heavy metal that is nothing but that mercury, right? What are the chemical industries? So here this is the scrubber, right? This is the outlet. This is that outlet. So source. This is the source. Okay. Body. Okay. Temperature meters. Emission meters. These are the parts of the particular scrubbers. That is nothing but first one is the outlet, second one is the emission meter, third one is the temperature meter. And the total, what are the large one which are mentioned here, that is all, that is nothing but the body, and it is the source. Where that particular industrial sources, what is that chemical industries, this is the source from this tube, from this tube-like structures, the dirty gases which are coming, and it can be entered into the body of the scrubbers. In that body, what are the temperature which will be maintained, and what are the emissions, and how much amount of the heavy metals can enter into this particular thing, particular body of the scrubber. What will happen? The scrubbers have the better scrubbers have the capacity to attract or to attach the what are the mercury compounds which are present in that particular emissions of the chemical industries, all the impurities and all the mercury compounds, and what are the remaining particles of the chemicals which can be absorbed by the scrubber like structures which is present in the body of this scrubber. After the removal of all the impurities and all the heavy metals, that is nothing but that mercury, that can be can entered into a outlet. This is the after coming that particular thing can through this pipe. Wait, it is not clear, I think so. Okay. After the cleaning of the chemicals, that can through this pipe, then that can be can enter escaping from this outlet. Okay, this is the emission meter, how much emissions will be entered into the body. This is the temperature meter, what is the temperature of that particular what is the temperature of that particular body of this scrubber. Based when we are going to observe this 2 meters from the outside, we can easily maintain the safe mode of that scrubbers using. This can be a, one of the most important thing to remove the heavy metals which are entering into the atmosphere by the chemical industries, right? um, yeah, this is the good thing. Mm. Yes, this is the explanation of this scrubber, right? This is another mode of the selective catalytic reductions. So already we explained that selective catalytic reductions. But in this diagram, just we are going to mention that that is a selective catalyte. In this also a catalytes will be there. See here, nitrogen, no oxygen molecules. These yellow things are the dust particles. Dust particle, ammonium shape, and NH3, ammonium. These are the catalyst. Catalyst. All the things. What are the reaction which will takes place and so this is the explanation of the SC or selective catalytic reactors. This, up to here, I think this is a clear. Mm, then coming to that next one. Oh, few more diagrams are there. Next one is the activated carbon adsorption. Activated carbon adsorption. This is also one of the important thing. Uh, so activated carbon adsorption. This is also one of the most important thing. Mm, this is also how that activated carbon can be observed. So how this technology will be used means already we discussed orally, but wait a second. Activated absorption. What is that? Activated carbon absorption. Where is this? Yes. Activated carbon absorption removes the volatile organic compounds. It is the most important method to observe the what are the volatile organic compounds which are present uh, in this industrial sources as a hazardous to the air. That is nothing but the hazardous air pollutants. How can be volatile organic compounds will be removed in this active carbon absorption? Let me discuss. Okay. Hmm. This is the one first chamber can be entered and it can. Okay. This is the first chamber, first one, and this is the second one. This is the third chamber. fourth, fifth, sixth, seventh, and eighth. In this activated carbon adsorption sessions, mainly six chambers are there. In that first chamber, the activated carbon will be included in this one. When that activated carbon can entered can and the activated carbon can entered into that second chamber, then what will happen, it can easily remove that what are the volatile organic compounds and what are the catalytes which we are going to use in this to control them, to digest or to break down the what are the harmful compounds which are present in that particular volatile organic compounds, what are the catalytics and what are the chemicals which can be mentioned in the chamber 2 and mixed with very well. When that particular activated carbons can come into the second chamber and react with that one, then what will happen, some reactions will be takes place. Some reactions here means the capacity of the pollutants, it may be a decreased, or maybe a volatile organic compounds can break down into a easier and similar compounds, not a hard compounds. It gets similar compounds. Here, why I am going to use that word similar compounds means that is also a environmental pollutants, but that harms the environment up to not more than 1 to 2%, that are the similar compounds. What are the complex compound means, that are nothing but the direct pollutants are the complex compounds which can be affect our environment uh, up to 80 to 90%. That's why after the mixing of the chemicals into that second chamber, that may be a breakdown, it can be changed into that similar forms that can be entered into that um, third chamber. In the third chamber, again it may be connected with that for three cylinder like structure, that is the fourth, fifth and sixth chambers. In this also some chemicals and some other gases and some catalyst will be there. When that volatile compounds can enter into the chamber 4, it can be reacted with that what are the chemicals which are present in the chamber 4. After the cleaning will be completed in this one, then can enter into the fifth one, and again completion that can enter into the sixth one. And finally, what are the residues and what are the harmful chemicals, which all the things which can be separated when that particular activated carbon can reach by that seventh chamber. After the seventh chamber, it can be totally pure. It can be totally separated. What are the impurities which are present in that one? Only the what are the pure or pure compounds, pure native harm, not that is not the pure, that when we are going to use that word as a pure, that is the wrong, and that is the not a pure thing, that is only a environmental friendly things. Okay, the environmental harming gases can converted into the environmental friendly gases and friendly compounds. That particular compounds cannot harm that environment at any cost. After that process which you are followed, that is named as activated carbon adsorption. And activated carbon adsorption, that is a good thing. Then coming to that next one, uh, landfill gas recovery. The next one is that sorry, what are all these things? The last one in this chapter, sorry, in this, yes, in this chapter is in this block 3 unit, last chapter, unit 12. Here is that last one is the landfill gas recovery. So what is landfill gas recovery here means, um, when we are going to fill the land, when we are going to fill the land with that what are the agricultural residues and what are the crop residues and what are the leaves and that what are the livestock wastes and all, just we are going to dig that a deep well like structure, that is not a well, just it may be up to some meters from the ground to the downwards. Then what will happen, just we are going to form a one digging structures will happen. We are going to fill all the agriculture residues, animal waste, and what are the excretory products of that cows, buffaloes, and cows, that is nothing but the dung, that are what are the vegetable wastes, and what are the plant residues, leaves, dry leaves, what are the branches, and all the things, what are the waste in that from that us in our surroundings, not only the natural waste. Here all the waste is here means that is what are the not a e-waste, not a plastic, or not maybe a clothes, not maybe any plastic boxes and products, and not a plastic covers. Only in that landfills we are going to fill that particular landfill with plant residues, and what are the animal waste, and what are the kitchen waste, only with that wastes only we are going to fill that one, and close that particular well with that soil and all. Then what will happen, due to the some pressure and the temperature in that anaerobic condition, some gases will be produced, that is nothing but a methane gas, or maybe a gobar gas, that is a light uh, golden in color. There is no smell of that particular one. That is a landfill gas recovery. So then what will happen after the landfilling is completed, after 1 week or 15 days, the gas will be produced. By using that connections, we are going to use that gas as a cooking fuel and all. This is one of the most important landfill recovery to can reduce the methane productions and agricultural waste on the surface of the ground. It is also a important one. It is a not a dangerous one. It is a very cheap and affordable to cost. Uh, uh, this is about that unit 12. This is unit 12, which are including in that black